Hello and welcome. Good evening to today's Rust meetup. I'm looking forward to approximately 2 hours of Rust with two hopefully great sessions. I'm very glad that we can do our Rust meetup today again. As every time, we will start our Rust meetup today with a short introduction and some community news. Let me quickly open up my slides and get them going. And here we are. Let's share the screen. Here we are. And this is it. Okay, let me quickly tell you a little bit about what's going on in the Rust community in general, in the community in our hometown Linz, and talk a little bit about things that are maybe interesting to you or hopefully interesting to you. This meetup is brought to you by the Coding Club Linz, which is our very own coding club. We do a lot of things, and the Rust meetup is one thing. And today's topics, today's sessions will be, let me increase the font a little bit here. Our today's speakers is Rainer, that's me. I will start up with Rust closures. Some new things happened in Rust edition 2021 in terms of closures. And I will do a little intro about how closures generally work in Rust. If you are rather new to Rust, if you are approaching Rust from a different programming language like JavaScript or TypeScript or C# or something like this, you might be interested in how closures work in the Rust language. And then we will take a look at some examples to understand what's new in the Rust edition 2021. After my talk, Stefan will do a session about Tokyo, Warp, and WebSockets. I'm really looking forward to that one, and I'm sure it will be a super interesting talk. If you haven't joined us yet, we invite you to join our Discord server. Here is the link. I will send the slides also to the Discord channel. Let me take this link and put it, here we are, and put it onto our chat. I will do that. I will do that momentarily. Give me a second. If you want to join our Discord server, here is the link. I just copied it. You are very welcome there. You can use the Discord server to ask questions, to meet with peers who are also interested in Rust and who want to learn Rust exactly like maybe you do. So the Discord server is a great opportunity for you to get in touch with us and with the entire community here in Linz. Now let's continue with some community news, as that's a kind of tradition for all the meetups that we do. And I'm going to tell you a little bit about some things that are going on in the community where we are involved. First, let's start with our very own Koda Dojo. For those of you who don't know Koda Dojo is a programming club for kids. And currently this week, we have something pretty exciting going on. In Austria, we currently have holidays. We have the so-called autumn holidays, Herbstferien. So all the students sitting at home don't know what to do. And we think that coding, recreational coding, is a great way to spend holidays. So we invited students to join us this week, Wednesday, Thursday, and Friday. We will do the Friday part to spend the morning, from the morning until noon, to do some coding and to learn something. And on Wednesday, the HTL Leonding did a program with all the kids using robotics and things like that. Today, the Fachhochschule Hagenberg did a full morning programming with Java and processing. The kids built a cool space shooter. And tomorrow, the Coding Club Linz will do a round of web development, and we are going to build a Halloween-inspired jump and run. So this is what we do this week for kids and students. We expect between 60 and 80 students, and I'm really looking forward to that. Next thing, our friends at Female Coders, they will do their next study group on November the 3rd. I think, if I can remember correctly, it will be a hybrid event, but I'm not 100% sure. So please make sure that you check whether it is an online event or an in-person event. Here is the URL of our friends at Female Coders. You can look them up there. They're also on Meetup, and I highly recommend, if you are female, highly recommend to subscribe there, and maybe you want to participate in their study group. Our next meetup is currently planned for 25th of November. This is again a subject to change. This month we had a little change. Last month I told you that we will do the October meetup on the 21st, but we had to reschedule because of a pretty tough business schedule that Stefan and I have currently to follow. So we had to postpone for 1 week. So now today we are here. For next week, we are currently heading for the 25th of November. And we already have fixed one guest speaker. He will speak about WebAssembly in the Azure Kubernetes space with Crustlet. Maybe you can remember that if you are a follower of our meetup. We already had some developers from Microsoft, from the Crustlet team here at our Rust Meetup Linz. And this time, Thorsten Hans will visit us, and this time we will do a lot of demos. So you will really see WebAssembly workload running directly in Kubernetes with the Crustlet project in the cloud. So I'm really excited to have Thorsten as one of our guest speakers, and we are currently looking for a second guest speaker. If you are interested to give a talk, follow the link to our website, rustlinz.at, and there you can find the Sessionize link to propose your sessions, and we would be very happy to have guest speakers. Last month we had 2 guest speakers. This month we will do the content our own, and next month we are aiming for 2 guest speakers again. So take your time and propose some sessions. We would love to have you at our meetup. Another event that is, in fact, happening tomorrow, the entire weekend. This will be our very own Games and LAN. It will be a Games and LAN festival. So if you are a gamer, you can take your computer, go to the Grand Garage and to the Tabakfabrik and have a weekend of gaming. If you are into paper games, pen and paper games, or Brettspiele, then also go there and participate. There are still spots free, so take a look, but bring your COVID vaccination pass with you, because you have to be vaccinated to participate in this event. And last but not least, I would like to point out the upcoming Rust Summit, which will happen at the beginning of December. Stefan and I have the honor to be part of the board there, and we will also do some sessions there. You will find some speakers there who were already in our meetup here, so it will be a very, very interesting summit. If you want to know more about it, go to entwickler.de/Rust Summit. We want to say thank you to Entwickler.de, because they gave us a special rebate code with which you can get the tickets with a rebate of 15%, in addition to other rebates which you can get if you want to have an early bird ticket. And we also got so-called diversity tickets. So if you are a member of an underrepresented group in the IT space, or if you are maybe a student and you would really love to go there because you might use maybe Rust for your diploma thesis or something like this, and you cannot afford this commercial event, then please get in touch with us, or we can make sure that you can apply for such a diversity ticket. There is a limited amount of tickets, but we are pretty sure that if you have a good reason why you want to go there, then we can help you in order to get one of these diversity tickets. So thank you to Entwickler.de for making that possible. And with that, we are through with the community news. Okay, I will, after my session, I will take the slide deck and convert it to PDF and send it to the Discord server again. Okay, so so that everybody can get a PDF version of these slides where the links are working. I see that Stefan is currently here. Should we bring him to the stage for a quick hello? I think we should. Yeah, here it is.
Hi, everybody. Oh, it's cool. I can adjust my light. Hi. Oops. Now it's broke down. I'm so sorry. Hi, folks. Hey. Thank you, everybody, for joining. I'm terribly sorry for being so incredibly late with my talk title. But hey, I prepared a couple of demos for you today. So let's see how this turns out. That I'm really looking forward to your talk, Rainer.
Oh, Stefan, that your session was really a cliffhanger. Everybody was watching the website. What will we talk about? What will we talk about? And finally,
I'm so sorry. I'm really sorry for everyone who waited for so long. I had the toughest of weeks, and I didn't have basically any time to to do any communication outside the most necessary ones. Mostly because I learned about futures and async development in Rust, but now I know everything about it. So I prepared, I don't know, about 200 slides or something for a workshop that I did today. And where we stopped at the workshop, this is something where we pick up right now. So maybe a couple of people who have been with the workshop today are joining us today. That would be great, because this is now the extra session. So now you're getting a little demo on WebSockets and how to do them with Rust based on the Tokyo stack. Also a little intro on the Tokyo stack. So yeah, that's what you're going to see today. Cool.
That sounds very interesting, and I'm looking forward to your talk. But I think I have to start, right? I think it's up to me to get started.
Go ahead.
And let's take a look at the watch. It's 20 minutes before 6, so I think we are right in time. And if you agree, let's get started, okay? Good.
All right,
very good.
Let's start.
So, Stefan, we will see you in approximately 45 minutes. So let's do that one, and let's add this one to the stream. Let's put it that way. Okay, very good. So again, welcome from my side. Now the community news is over, and we are going to focus on the next session, and it will be all about closures, closures, closures. Okay, so my talk is based on a column that I wrote for Heise.de. It came out a few days ago. I think on Wednesday last week. So I will take the material from this blog post as the basis for my talk. If you are interested in reading the entire talk, it's in German. Then I can share the link in the comment section or put it on Discord. I will do both. I think that's okay. But today I will do it in a talk format. So I have taken all the samples and I will walk you through and describe what closures are all about and what's excitingly new in Rust 2021. So for that, I have taken a sample project and I've created some snippets, because in 45 minutes, I cannot write so much code. And those who have seen my talks before, I frequently use snippets so that I can bring in more content without you watching me mistyping. So I've prepared snippets and I will walk you through the entire content. Good, let's get going. Let's start with a very simple example. And my first one is this one. Okay, and let's run this guy. Let's run a cargo watch down here, so you always see the result, what's going on. I think I can move that one here up, and I think we are good with that. So let me quickly zoom in a little bit and show you. Oops, first we will do the following. Sorry for that. And now I will... Yes, now I can make it larger and smaller just as we like. I think that is good. So let me quickly introduce you to closures in Rust. That's the 101 of closures. If you are not that experienced with Rust, this is what a Rust closure looks all about. You might be familiar with terms like lambda expressions or lambda functions or arrow functions in JavaScript, and this is the syntax of such lambda functions or arrow functions in Rust. They are not arrow functions, as you can see, because you use the pipe symbol to specify the parameters, and then you specify the body of the closure, just as you can see it here. I was told that this may be similar to how it is done in Ruby. I've never written any line of code in Ruby. If you are a Ruby developer, let me know in the comments section. I would be interested. But for me, coming from a C#, TypeScript, and JavaScript background, that syntax was a little bit new. So let's take a look at the code. Here we take a variable x, and we have a getAnswer variable here, and this variable is essentially a closure, because when you take a close look, you will see that this function, this one, captures the variable x from the environment. So the environment has the variable x. It is captured inside of this closure. And at the end, we get the result 42 because we call the method, as you can see it here, with the parameter 21. So that's nothing special. That is how a closure works. And in the next half hour, we will dive a little deeper into how this stuff really looks like. So let's take a look at the next one here. So, okay, this one is empty. That's by design. And let's put it here. Let's do a bunch of demos about syntax. Let's first focus on the syntax. Please take a look at line 5 and 6. These are the first two lines where I would ask you to take your to take a look at. In line 5, we define a regular function, which is the add function, nothing special here. And in line 6, we assign the add function to a variable f. And what you already see from the Rust analyzer, that f is getting the type fn add i32, i32, i32. So we see this small letter fn here, which is essentially a function pointer. This is technically not a closure. It's not capturing any environment variable. So this is just a function pointer. This is not already a closure. You can use this one whenever you need a function pointer. And of course, you can use this function pointer to call the method. You see it here. Very simple. And you get back a result, and it works perfectly fine. Now, the idea of the closure syntax, we can try that one here, goes in that direction that let me zoom in a little bit, that we essentially remove the fn and the name. We don't need to come up with our own name. Instead, we take the variables, as you can see it here, and we move them between these two pipe symbols. The rest is essentially the same. The return type is inferred automatically from the return expression. Everything else works as expected. But we can simplify this in Rust even more. We can do something like this. If you take a look, if this is just a single line expression, we can remove the curly braces to make the syntax look even nicer. Rust is smart, especially when it comes to type inference, so we can make this one even smaller. As you can see it here, I removed the i32 and i32 here. This is inferred, this type, by the Rust analyzer. This is not part of the source code, and still it works. Why does it work? Because the Rust compiler takes a look at the call to f, and it infers the types for x and y from the call to the function f. This is still a function pointer, a lowercase letter fn, but this time I use type inference to let the Rust compiler come up with the correct type. The last example that I would like to show you here is not the best coding style in Rust. It's not considered to be good coding style. We will get a Clippy error, but still it works. So I decided to let it in and to show you how this is done. What you can do is you can define an inline closure, as you can see it here, same closure as before, and you can immediately call this closure directly here after the declaration of the function. So this is possible. It works fine, but Clippy complains. So Clippy says, hey, assign this closure to a variable, and then you can call it, similar to up here, where I assign the closure, the function pointer, to a variable, and I call it down here. So this is considered not the best coding style, but still it works. Now you have seen it. Okay, maybe it was a little bit interesting. Good. So this is the basic syntax of closures in Rust. That was 101. We have to dive a little bit deeper. Let's do that. Let's take a look at this example. This example defines, as you can see it here, a function add. I will zoom in a little bit so you will see it again. This defines a function add as we've seen it before. But the big difference to the very simple samples that we saw before is that we are now doing a little bit of functional programming. So I define a second function. Let's use a different color here. And I would like to draw your attention to the third parameter. The strategy for calculating the result this time in this function is not hard-coded. This function gets two parameters, x and y, and the strategy for calculating the result is passed into calc and print using a function pointer. So please note the lowercase fn here. This indicates a function pointer. which will receive an I32 and a second I32 as a parameter, and it will result in an I32. So therefore, we can, and let's go back to red again, we can pass in the add function, which we have defined up here, and it works perfectly fine because this is compatible with the definition of the calculator parameter. We can also use a closure, although calculator is not a closure type, which we will learn about in a second. In this case, it's a function pointer, but this is perfectly fine as long as the closure does not capture any environment variables, any variables declared outside of the closure. Everything is okay. So this one is now the calculator without a function definition. It's an inline function and specified as expected, as we have seen before. This I32 and I32, the types are inferred here, so I do not need to specify them manually. Works as expected. If I run this, I will get the result 3 and 3 two times because add and this closure, they do essentially the same. So this is a function pointer, and now you have learned that you can use closures wherever you want to have a function pointer. But when you really have a closure that captures a variable that is declared outside of the function, of the closure function, then this fn does not work anymore. So if I go here and try to do something like this, I get an error. And this error is by design. Let me show you what's going on here. I have defined another variable which is called z, and I have used this variable z inside of my closure. So I'm now capturing a variable from my environment. And this is no longer a function pointer. In fact, if we think about how this can work, it is super important that this does not work. Because this expression, this closure, cannot be represented by a simple pointer to a function. We have a function which needs access to external state. In this case, it needs access to the z variable. And therefore, we need a different data structure. Just a function pointer is not enough anymore. So this does not work. We have to think about how we can solve this problem, and we have to think about how we can make this work with a different type than just the small letter fn here. So let's remove that one and go into the next demo. This demo looks very, very similar to what you have seen before. Let me zoom in to make sure that everybody can read it properly. This time, if you take a close look at the code, I'm not using the lowercase fn anymore, but I'm using the fn trait with the uppercase f here. The uppercase f is, as I said, the fn is here a trait. Therefore, I need a dynamic dispatching. I need a trait object, which I have to put on the heap in order to make it work. So why is that important? Well, think about it. Here, this works as expected. We only have to put the function pointer in a box, and then we can pass in a regular function pointer. Check, works as expected. If we have a regular function, as you can see it here, a regular closure which does not capture any environment variable, everything is okay. We only have to be explicit in putting it onto the heap in a box, because that is how Rust works. Rust is very explicit. There is no magic happening by convention. You always have to type what you really want to do. And therefore, we have to put the closure into a box in order to be able to pass it to our calculate and print function. The interesting thing comes down here, because this time we can take this closure which captures the C variable, put it in a box, and it works perfectly fine, because now we have a trait object. What's technically happening behind the scenes, at least conceptually, not technically at the very low level, but conceptually, what's going to happen is the following. Let me show you that one. What's going to happen is we are going to get a kind of, as I said, conceptually, we are going to get a structure where we store the captured variable, as you can see it here, and the structure also holds, as you can see it here, the logic of the closure. We will get, at the end of the day, we will get a structure, and here you see it, and we will pass in a trait object which represents, as you can see it here, the structure consisting of the captured state plus the method which operates on this state, and of course the parameters. So conceptually, behind the scenes, you always have to think, when you talk about closures with the uppercase F, that behind the scenes you get kind of a structure with data, state, and functionality. This is also the reason why sometimes, let me go back one element here, that sometimes you have to specify, oh my God, a lifetime for a closure. Because in this case, Rust needs us to specify a lifetime, because it is important that the lifetime of the variable fits to the lifetime of the function. That's essentially the structure behind the scenes. In this case, we do not have to write the lifetime manually. We can use lifetime elision here, because Rust will come up with the correct lifetime, but it would not work if you do not specify this one here. If you try to do that, we will get an error, and you can dive into the error later if you are interested in why we have to specify a lifetime here. I only today have 45 minutes, so I will not go into the details. But at least a little bit, it should become clear when you remember that having a closure is essentially another form of writing conceptually a structure. Okay, and there we already know that sometimes or often we need lifetimes. Okay, that is the uppercase Fn. Unfortunately, the story doesn't stop here, because this uppercase Fn is just one trait for closures out of 3. In total, we have 3 types representing closures in Rust. Fn is the first one. The Fn, the uppercase Fn trait, means that we are not mutating the captured variables. We can mutate the captured variables if we use the trait fn mute instead of fn, and this is my next demo. This example is split it in 2 parts, and I will zoom in and I will walk you through the code. First, draw your attention, please. Let me draw your attention on these 3 lines. As you can see, this calc result closure calculates x plus y, but the result is not returned, but the result is written into a captured variable. So in this case, I'm mutating result. So therefore, this is not just a closure, it is a mutating closure. If it is an fn mute. We don't see that if we just use these 3 lines 5, 6, and 7. Because here you see, I'm just calling it result, everything is fine, everything is good. But it becomes very clear if we take a look. Oh, that's maybe a little bit too wide. Let me do it like that and zoom in again. If we try again to store this closure in a variable and write the correct type, we will see that we can no longer use the fn trait here. We have to use the fn mute trait, because only with that we have a mutable borrow of the captured variables. I can show you that if I remove the mute here, I will get an error here. This does not work, as you can see it here, because the captured variable is an fn closure, and therefore we cannot assign a value to the variable result. What we have to do is we have to change that to an fn mute, as you can see it here, to get a mutable borrow inside of the closure. And then everything works as expected. Let's make it here. We put it in a box as we did it before, and then we can call the result calculator, and everything is okay. We can drop the result calculator. That's fine here. And then we can print the result. That's perfectly okay. That was an fn mute. So let's quickly recap. Fn for capturing variables with just a borrow, read only, immutable borrow. Fn mute for capturing variables for mutation. So the third one, I told you that there are three, is fn once. Fn once means that we are moving ownership into the closure. Let's take a look at these two examples. I think they should fit on the screen quite nicely. Yes, let's take a look at the first one. I would like to draw your attention to the first 4 lines of code. As you can see, I define a vector with some numbers, and then I get an iterator into numbers iter. Then I would like to do the sum over this iterator. And in order to do that, I have to move the ownership into the closure. I can use the keyword move to essentially move all the captured variables into the closure. Now the closure is the owner of this iterator. And with that, I can call the fn once here, and I will get a result. In this case, the sum of the numbers 1, 2, 3, 4, 1, 2, 3, 5, 6. Okay? I forgot the 4. I don't know why. It becomes even clearer if we take a look at the second part. Let's use a different color here, this one. Because in this case, I'm storing the closure in a typed variable. And the important type here is this one, as you can see it here. This uses the fn once trait. And the fn once trait is okay because we are again using the move keyword here. We are moving the numbers iterator, the ownership, into the closure, and therefore the result will be an fn once. We can only call it once. We can only call it once. Okay, so we have fn for immutable borrow, fn mute for mutable borrow, fn once for taking ownership. You might ask yourself, why do we need that? Why is this move so important, and why does Rainer tell us about it? Well, one of the most prominent use cases of fn once with a move keyword is working with multiple threads. Let me show you a quick example. In this example, please note that we have a counter and a counter string outside in the main method. Then we spawn a thread, as you can see it here, and we are using the move keyword to create an fn once. We are capturing the variables by taking ownership. As you can see here, I'm just incrementing the counter. If the string is not empty, I'm adding a comma here, and then I push to the string the counter value, and after 5 elements, I'm breaking, and we are waiting a little bit. So at the end, I'm joining, so I'm waiting for the thread to continue, and if we try to run this one, the counter string here, it doesn't work. The counter string was defined here in the main method, so you might think that we still have ownership here in the main method, but we don't. Because of the move keyword here, we moved ownership of the variables into the thread. And that's important because we explicitly want to give ownership to the thread, and we do not want to have a chance to for instance, access these values by design in the main method. That might result in some kinds of race conditions or similar bad things, and therefore the move keyword is super important here. We are moving the captured variables, the ownership of the captured variables into the closure here. Okay, so this is an fn once, an application that you see pretty frequently when you do multi-threaded programming. Okay, good. Now let's think about what has changed in Rust 2021. Now you have the basics. You have learned about function pointers. You have learned about the fn trait, the fn mute trait, the fn once trait, and now we can build on that knowledge and take a look what changed. This is the sample that you frequently see when you take a look at what's new in Rust 2021. Let me quickly describe it, and I will describe it by switching to the edition 2018. So let's wait a second, and as you can see, we get an error. And this error is by design. Let me walk you through this code, okay? Now, here you see you have a structure, something. It consists of anything and anything else. The constructor assigns foo and bar to anything and anything else. The important thing comes here. We create something, and when we explicitly drop a member of something, anything, we drop only one member. The other member is still okay. And if you now take a look at the closure down here, you will see that we are capturing something.anything else. We do not capture something.anything, as you can see it here, but we capture the other member of the structure. And up to Rust 2018, this was not possible because in this case, Rust would capture the entire object, the entire instance of the structure. So therefore, we cannot access st.anything else, and we get an error. Yeah? Use of partially moved value st. This is exactly what Rust 2018 gives you. Now, if we take a look here and switch that one to 2021, let's wait a second until it is continued. We see already in the output down here that now we get a result. So if we take a look here at the main method, oh, sorry, I still have this clippy error, but for demo purposes, it's perfectly fine to call it here. The point of this demo is that I no longer get an error. We still capture st.anything else. It is perfectly fine to access anything else because we have only dropped anything and not anything else. So the capturing is no longer done on the structure level, but it's done on the member level. And this is called disjoint capturing inside of closures. Disjoint because we only capture one element and not the entire structure. You can force Rust to move everything in it if by just assigning the entire instance of the structure to a local variable inside of the closure, and then you can enforce the behavior that everything is captured. But by design, this is a breaking change. By design, it only captures the member of the structure. Now you might ask yourself, why do I need that? Where is the advantage? Where is a use case? And I tried to come up with a simple, little bit funny and entertaining example that should bring everything to the point. I don't know about you, but when I was a child, I frequently heard the Cinderella, the tale of Cinderella, Aschenputtel. You maybe know it from German. If you have taken a look at the Cinderella movie from Disney, you might not know how it really worked in the original book. There, Cinderella, when the bad sisters threw out the lentils on the floor, then Cinderella had to go through all these lentils and put away the small ones, the bad ones, and keep only the good ones, the big ones. And a lot of pigeons came, and these pigeons had I have to say it in German because I don't think that they translated it in the film in English. It said, die Guten ins Töpfchen, die Schlechten ins Kröpfchen. That means they had to eat the bad ones and keep the good ones. And I want to implement this Cinderella tale using Rust in a way that I can describe how disjoint capturing in closures work. Let's see if I can do that, okay? So we start up with a very simple structure, which is a lentil, and it just contains a size. Now, the second structure is the interesting one, because in this case, we have a Cinderella task. This Cinderella task comes in with all the lentils that are spread across the floor. This is the vector of lentils. And then we have a strategy, the strategy that Cinderella gave the birds in order to help her. Okay? She said to the birds, hey, eat the bad ones and put the good ones into this box. Okay? And this is exactly what we have here. We have all the lentils, and then we have a strategy where we pass in a trait object based on the fn trait. Can you remember? That's an immutable borrow of a single lentil, and then we return an indicator whether the bird should eat the lentil or it should capture the lentil in the box, so that the lentil keeps the same. Okay, so this is the kind of Cinderella task that we have here. Now we implement the Cinderella task, as you can see it here. And here we see, here the magic comes in. Because in the implementation of the Cinderella task, I implemented a method which is called sort lentils. Sort lentils operates on the Cinderella tasks, and it uses the retain function, which you might already know. It's going through the vector, and it only leaves that one that really are fine. And in this case, I am capturing, as you can see it here, I am capturing the eat method here. The eat strategy up here, the closure. This is what I wanted to show you. We pass in the lentil here with the eat method, but we still access down out there the lentils, which are also part of the Cinderella task. So if this method here would capture the entire self, then I could not access the self.lentils here. Let me prove the point here. Let's go to cargo toml and switch to 2018. Compile everything, and it does no longer work, as you can see it here, because we cannot borrow the eat function here, which is, in this case, a closure on itself. And here we again borrow the lentils, and this does not work. Only in 2021 this is possible. Now we have disjoint closures, and these disjoint closures enable us to here capture the eat, and here access the lentils, and everything is fine. So let's check whether this really works. As you can see it here, I define some lentils, and these lentils are of different sizes, 5, 6, 1, and 2. And then I set up a Cinderella task where I define that a lentil has to be eaten if the size is smaller than 5. Then it's a bad lentil. The birds are allowed to eat it. That's my strategy. And this strategy is formed in here, as you can see it here, as a closure. So I put that into the eat strategy. Together with the lentils, they become the Cinderella task. Then I call the sort lentils method, and what remains are 2 lentils, the lentils with size 5 and size 6. And that's exactly what I want to have. So this is hopefully an example where you see that these disjoint closures are really interesting. They are useful. You can use them in real-world examples. Nice. This is what I wanted to show you. So let me switch here and let me quickly summarize what we did. I wanted to show you how closures work in Rust. We started by taking a look at the basics, the 101 of closures. We took a look at the syntax of closures. We compared it to other languages like JavaScript, TypeScript. We saw that we use the pipe symbols instead of arrow functions here. We saw how Rust is smart in inferring types of closure. It works pretty well. Then we analyzed what's the difference between the lowercase fn and the uppercase fn. One is a function pointer, which is just a pointer without any state, and the other, the uppercase fn, is called the fn trait. The fn trait is really what makes a closure. So the uppercase fn represents behind the scenes, at least conceptually, a kind of structure where we have data inside of the structure together with the methods that operate, that capture these variables. After looking at the uppercase fn trait, I showed you that there is also a mutable fn trait and an fn1 trait for taking ownership. So we have fn, we have fn mute, and we have fn once. And now if you get an error from the Rust compiler that something is not compatible with fn once or something like this, now you know that you have to take ownership and use the move keyword. So I hope my description helped you understand the messages of the Rust compiler, and it helped you understand what's going on behind the scenes. Last but not least, in the last few minutes, we took a look at what's new in Rust 2021, disjoint capturing in closures. I showed you in a Hello World sample that Rust is no longer capturing the entire structure, but only those parts that you really use. And at the end, we did a little bit fairy tale programming. We used the Cinderella tale, and I showed you how we can use the disjoint capturing in a data structure where we have the data and the closure operating on this data in a single structure. And we used capturing and closures to execute the closure onto this data. This is what I wanted to show you. And if I take a look at the watch, we still have a few minutes to go before Stefan will take over. So for now, I will take a sip of water, and I encourage you to ask questions if you have questions. I see Stefan is already here. So I will bring Stefan onto the stage if that's okay for him. Please give me a thumbs up if that's okay for you. Okay, here it is. Stefan.
Hi, I'm
welcome.
back.
Welcome back. Let's put it this way. And let's take a look at the questions, okay? So, what do we have? Hello and good evening. Yes, hello and good evening back. I really hope that you enjoy the Rust meetup. So, let's take a look. What do we have here? Why box new is not a heap new or alloc on heap? That's a good question. Stefan, do you know why in Rust box is called a box? Let me show you the question. I often get this question about heap and box, and in one of my workshops, I came up with an analogy. Let me tell you that story. Maybe it's a bad analogy, but maybe it helps you remember that. Remember Christmas, okay? You have the presents, and you want to give a present to somebody, and you want to put it on the heap of presents under the Christmas tree. What do? You take the Christmas present and put it in a nice little box so that you can take it and put it on the heap below the Christmas tree. And that's exactly what's happening. And for me, I'm always thinking of a Christmas tree and Christmas presents in boxes and a heap of Christmas presents under the Christmas tree, and then I easily remember boxes. Okay. Do you think that's a useful analogy? I'm not sure.
Yeah, so absolutely. I usually have a warehouse in mind or something similar like that, where you put all the stuff in a box and shove it into some shelf and keep it there. And then you have this warehouse like in IKEA, where you were looking at all those shelves, taking your boxes, and then you have to find it based on the number. You look around in this big shelves at IKEA, try to find your box with your stuff in it, and then you get it and then you unpack it. So that's my analogy for that. And I don't know the term boxing. If you box something and put it on the heap, that's as old. That's as old as I don't know, C maybe. I guess that even existed since those days, or maybe even longer. And we got so used to this term. I guess
absolutely.
so.
In C#, for instance, it's also called boxing and unboxing.
It's also called boxing. Yeah.
If you take something that is on the stack and you operate on it in a certain context, we say the operation, and it's even in intermediate language, it's called boxing and unboxing. So box and unbox are the intermediate language statements. So it's very common across many different languages. Thank you for this great question. It was interesting to speak about it. So the next question that we have here is, what if we don't want to modify a variable that was moved into a thread and we want to use it after thread creation? What do we do? What you have to essentially do if you want to share memory across threads is to use some of the advanced data structures like mutexes or RW mutex and RW lock and things like that in order to have some controlled shared memory. And you move in the mutex. You capture the mutex, not the data structure itself. Okay, that would be an answer. I hope that helps you. That puts you on the right track here. Oh, Carlos liked my example. Stefan, I know your kids just came back. I showed a Cinderella example. So I did
That's good.
Cinderella programming, and I have taught birds to eat lentils in a Cinderella task. So I think, yeah, Carlos liked the example. I thank you. Thank you very much. Sergi says that in Java, casting from int to integer and back calls boxing and unboxing. Thank you. Thank you very much. It's very similar to what I know from C#. So it seems that I have no idea about Java. It seems that C# and Java work similarly. But in Rust, as I told you, in Rust, all of these things are very explicit. You have to explicitly do something. It is not done magically behind the scenes like in C#, and I assume in Java too, you have to explicitly write code. That's kind of in the nature of Rust, isn't it, Stefan?
Yeah, absolutely. So this is one of the key philosophy things in Rust, that you have to be explicit with everything that you do. Either be it error handling, even if you ignore an error, you have to unwrap it explicitly, or you have to bubble it up explicitly. If you want to have a copy of a pointer or a clone of a pointer, you have to do it explicitly. You can't do it just by using it. There's no convention for that. I guess the only convention is copy. If you have numbers or something, so you have the copy trait where you can move out values from the stack. But everything else is very explicit in Rust, and this is actually one of the things that I like most about it, that you have to be so explicit, because it's easier to reason about your code in that way. So yeah.
Mm-hmm. Yep. Thank you very much. Thank you. Yeah. I think if I take a look, I was just looking through the questions. There is one question which is not related to my talk. I can take a look at that one later on, but I don't see any open. What did you see to draw arrows and boxes on top of code? Okay, now I understand it. I was now again thinking of arrows like in arrow functions and boxes like in boxing and unboxing. But I think what you want to know is which tool I used to draw the arrows and lines on the screen. This tool is called Zoom It. Zoom It, it's for free. It's a very small executable. I think it's only available on Windows, and I use this tool, Zoom It. Just Google it. You will I'm pretty sure you will find it. Stefan, I think some similar tools are available on Mac too. I'm not a Mac user. If you can recommend such a tool. Yeah, Hans-Peter already.
So one thing that I found out is zooming in the screen and zooming out of it. I haven't found a tool to draw on it, unfortunately. That's why you get PowerPoint presentation from myself.
Okay, awesome. So Stefan, I think everything is fine from my side. We are 7 minutes early, but I didn't use the full time of the community news at the beginning, so I think we are right on track. Are you ready for your talk?
I don't know if I'm ready. I try my best. So if I screw up anything, please bear with me. I had a rough day. I had a rough week, but I also want to share a couple of things that I played around with. So it's not a talk that is very, very structured or very elaborate. It's just, hey, I did something. This is what I want to share with you. This is also part of what we do here with Rust Linz. It's also about exchange, about learning, and this talk is dedicated to Elvin, who's online today, because I know he was looking for some solutions on working with WebSockets. And this is one solution that I found out because I was working with WebSockets a lot and was scratching my head a lot, tried different frameworks. And this is one that I was able to solve. So yeah.
Okay, Stefan, we are curious to see what you found out, and I'm looking forward to your talk.
Thank you very much. So yeah, I'm also very curious what comes out of this one. And let me put my screen online. So I hope you can see my screen. I can see it. Alrighty. So hey, we are talking today about Tokyo, Warp, and WebSockets. So hey, yeah, that's me. Hi, I'm Stefan. I have the worst Twitter handle on the planet. It's that parrot. So if you aren't into Monty Python, you maybe know what it means. If you aren't, don't worry. It's 60 years old or something. And today I want to talk to you about Tokyo, Warp, and WebSockets. This is So I've spent a lot of time trying to learn async, trying to teach async in Rust. It's interesting. It's very different to what I'm used to from other programming languages, but also once you get it, it's really one of those mind-opening things. And I want to talk about it some other point. Now I want to talk about an actual application that I wrote with async in Rust. I use the Tokyo framework for that. So Tokyo is fun because if you've done anything async or anything web related in Rust, chances are that you have stumbled on Tokyo in one way or the other, either by seeing some hash Tokyo : main thing. Maybe if you deploy the Lambda on AWS Lambda or something in Rust, then you use that because the AWS Lambda runtime uses it. Or if you've written a web server, be it with Rocket, if you used Rocket, which was one of those talks that we had here in Rust Linz very early on, then you've used Tokyo, even if you didn't know it. I think also Actix, so basically any web framework out there is based upon Tokyo. It's a multi-threaded runtime for executing asynchronous code. It has an asynchronous version of the standard library and a large ecosystem of libraries. There are some alternatives. Glomio is one that I just found out about recently. Async standard is, I guess, the other big alternative to having an asynchronous runtime for Rust, which is honestly one of the better ones to learn async because the surface is a lot easier to understand because Tokyo can get very big very early on. But if you reach one point where you are working on the application layers, usually stuff is mostly done in Tokyo. Why do we need a multi-threaded runtime for executing asynchronous code in Rust? So Rust gives you all the primitives for writing asynchronous code. It gives you futures to write something that is executed at some point in time and returns a value. It gives you async and await to have syntax sugar to work conveniently with asynchronous code, but it doesn't give you a runtime to execute it. The reason is Rust wants you to choose the one that's best for your system. You could write asynchronous code for an embedded system and you might want not to use Tokyo for that because Tokyo might not be the right choice for that. Maybe it's async standard. Or maybe you have different concerns that you need to take into account. And for that, you have to choose your runtime. And the runtime is the one thing that takes all your futures, all the asynchronous bits and pieces, and executes it on a thread or multiple thread, depending on your flavor. So Tokyo is not only a runtime, but Tokyo is also an entire set of tools. It includes everything from low-level I/O up to type system-based service modeling and anything in between. So we have Mayo, that's short for Metal I/O, and it's some sort of abstraction layer on top of operating system events. Like, oh wow, there's a socket done. Please do something, dear application. That's coming from Mayo. It normalizes the I/O across all operating systems for apps that you build on top of it. Then we have the Tokyo runtime, which is the heart of Tokyo. It's the asynchronous runtime. It implements work stealing if it's multi-threaded. So you have a queue of tasks. Task is a unit of process in Tokyo land. And you have a couple of threads that spawn workers which can work on those tasks, and they just pick a task from a queue, execute it if there's something to do, or put it back on the queue and produce results. So that's what Tokyo does. It also comes with a rich standard library. They have async file I/O, async network I/O, timer schedules, all that jazz. That's all there in the Tokyo runtime. And this is already great. And if you're at that level, you can pick and choose whichever runtime that you like. There are plenty out there. Tokyo might be one of the most popular, but there's maybe others that are better suited for your needs. And then there's even stuff on top of that. And that's a couple of layers. First is Hyper, which is an HTTP implementation, a correct HTTP implementation for Rust, which implements HTTP 1 and 2 for both client and server, which is basically the framework basis for anything XM, Rocket, Warp, Actix, you name it. That's all based on this package. We have the same thing for gRPC. It's called Tonic. It's also a layer on top of Tokyo, which implements the gRPC protocol, and you can work with that. And all those protocol implementations get around the idea of a service, which is done with Tower. So think of it as a middleware layer where you have different middlewares, different layers on top of each other. You can build a tower. And then you run a request through this tower down to the bottom. You get a response, you run it up again, and then you can modify requests and responses like, oh, there's an HTTP response which I want to gzip. Then you run through the gzip layer, and maybe you want to have a JOT token validation. Then you run through the JOT layer, or maybe you don't want this to take really long. Let's have a timeout layer so you can kill some of those requests if it's not worth working with them anymore. So this is Tower, and all those things build up. All the things that we see then are building up upon Tower. We also have a couple of packages that help us with the whole thing. Bytes is basically a synchronous reference counter mutex on U8. That's cool if you want to manipulate byte arrays across threads, and tracing if you want to monitor, if you want to send your data into Datadog or Dynatrace or whatever. So that's this part. Well, and on top of that, we also have frameworks. And frameworks like Axum, which is pretty new, which is from the Tokyo team themselves. It's also in the Tokyo organization on GitHub. And Warp, which is one of the Tokyo maintainers, one of the hyper maintainers from Sean MacArthur, which I guess that's a pretty wild guess. So Sean, if you can see this, and if I'm totally wrong, I'm sorry. Warp is, I guess, inspired from a Haskell framework that's named similarly, and you can see that if we look into an example, it's very functional and very compositional and filter based, and I think it's beautiful. So I liked working with that a lot. But yeah, so those are a couple of frameworks, but there are others, and you can see Tokyo basically anywhere. So one thing where I had to work a lot with Tokyo is Deno. I'm using Deno in a couple of projects, not just as a runtime that I can install as a binary, but I use the runtime itself to work on a couple of JavaScript projects. More than 5,500 crates depend on Tokyo, and that's crates, not applications. So it's really, really popular. All right, but what we're going to see Warp just in a bit. What Tokyo also gives us, and that's very inspired, I guess, by Go, and how Go works in terms of communicating with Go routines, which is their version of executing asynchronous code, is channels to share state. And I want to quote Rob Pike, who said, if you run concurrent code, if you run things concurrently, don't communicate by sharing memory, like a mutex, like an RW lock or something. Share memory by communicating. So you get a couple of channels where you can send messages through and you can pick it up from your other tasks. You have those independent units of executing things, and you send data in between them, and you're good with it. There are a couple of things, a couple of implementations in Tokyo. There's MPSC, which stands for multi-producer, single consumer. So you have a lot of producers, many taskers can create value, and you have one consumer that gets them. One shot, which is just sending one value once and then it's done, which is great for communicating back. So you can, for example, use this send the sender pattern, where you send something to your consumer and you get the sender where you can send back to the producer. So you can do this back and forth, which is great if you have some architecture where you have the web layer completely separated from everything else. This is where I use that a lot. Then you can communicate between two parts of your architecture without them even knowing from each other. It's just message passing. Watch and Brokers is multiple producer, multiple consumer, with a bit of different flavors. So there's a lot of stuff in there. So the tasks operate independently, and you can send messages in between to synchronize. And yeah, channel support sending a message from one producer task to one or more consumer tasks. One that we are going to see right now in an implementation, this is also available in the standard library, in standard sync and PSC, is multi-producer, multi-consumer. Send work to a task and receive the results of many computations. Multi-producer, single consumer channels have a capacity, but they're also unbounded variants. So this is the idea. You have many producers, you send it to one consumer. Alrighty, and you know, those are many producers, but this also could be just one producer. So we have also one-to-one, but with multiple computations. Here's a little example. So I have, I hope you can see my cursor, because I don't have those fancy arrows to draw on the screen, but here I have an async function main. I create a new TCP stream. I connect to some server, and then forget this line. This is not so important. This is more important. I create a multi-producer single consumer channel with a capacity of 100. Okay, and then I create 10 Tokyo tasks with Tokyo.spawn, and I do that from 0 to 10, so 10 tasks in total. I clone the producer, and a clone from a producer just creates another producer. It doesn't create another channel. It just creates another producer, which means I have many producers that talk to one receiver, but I need to clone that so I can move that into this async move here. So this async block, which is a future. So if I write async move here, it creates a future that's being executed in the Tokyo task that Tokyo spawn does. And once this async, once this future is executed, I can send some data to this channel. And down there, I'm going to receive it. So this is also pretty nice. This is a Tokyo stream. So this is some sort of asynchronous iterator. Even if you look at the trait definition, it's also very, very similar to an iterator, which is that you have an option that returns an item, but it's also something that's packed in a future, so you need to wait for it. So you can use it like an iterator, but it's asynchronous, so it runs somewhere in this whole task execution on Tokyo. And yeah, so if I get some data here, I write everything out. And one thing that is important, this receiver returns none, so it's an option. Either I have a value, some value, or I have no value at all. And if I have no value, it returns none. But it only returns none if all the producers have been dropped. And this happens, if this block here ends from the async move block. If this move block ends, TX gets dropped because, hey, freeing memory, that's the ownership model of Rust. But the original producer is still available. That's why I need to drop it manually in this case. So I need to drop that. So the rx.receive returns none at some point, and I can stop the execution of my program. So this is one of those channel types that are available in Tokyo, and this is also the one that I want to focus on today. So there are a couple of more, and there's great documentation out on all of them. But this is one that's interesting for what we are doing just in a second. Alrighty, and what I want to do is having a simple WebSocket chat. And this is a very, very stupid architecture diagram. I have a client, that's a browser up here, and I create a WebSocket connection to some server. So this is the world symbol for a server, which is a cylinder. I don't know why, but that's the world symbol for a server. And or is it for a database? I'm so sorry. I guess I totally forgot. But I'm creating a WebSocket connection, which is I have something to receive. That's Rx is for receiver, TX or TX is for transmitter. These are terms that come from broadcasting, actually. So from radio broadcasting, you have a transmitter, you have a receiver, and the abbreviations for that were TX and RX, and we carry them until today, even if we do either sockets or just channels or whatnot. So I have a user RX, which is a receiver, so I get messages in from the browser. This is the one socket connection, and I have TX where I can send back to the web server. And I do this for every client connection, for every browser connection that establishes a WebSocket to the server. Once I get a message, what I do is I send this message to every user, and I create an MPSC channel for every user. So every user has the possibility to send messages to one or more receivers, to one receiver. So I broadcast this to every TX that I have for every user that is connected. This message goes out through the channel, and it comes in on whatever receiver that is, and it goes back to the user TX, to the user transmitter. So this is a sort of round trip that I do. This is everything that I do with the WebSockets. I establish a connection, and I'm using channels so I can communicate between all those connections that I have by keeping track of all the senders and sending out stuff. Alrighty, and this is what we're going to see right now. let's remove my presentation and give me a second. Let's go to Visual Studio Code. And that's the web socket implementation itself. That's Warp. And as you can see, it's very busy. It's very, very busy because the moment you want to abstract a lot of stuff with for web servers or whatnot, you end up with a lot of types. And if you end up with a lot of types, you get type annotations the size of War and Peace or something. So really, really huge. Nonetheless, for right now, so that you can scan this and see what's happening there, let's remove the inlay hints. And if you learned one thing today, that you can remove the inlay hints. So it's a little bit less busy to look at. Okay. So what I'm doing here, I create a new Warp server, and Warp is funny because you are connecting bits and pieces to create routes and to create callbacks for that or stuff that needs to be executed, and it's then and or. So it's just connecting little filters together, and then you have a big filter tree. And when a request comes in, it gets filtered through, so it finds the right and the last stuff to execute. And this is very functional. This is very Haskell-ish, if you will. But it's also a lot of fun to use. So especially if you have a little love for functional programming. Alrighty. So let's start with something easy. One that I do, which is great for starting a web server, is serving a static directory, a directory with static files in it. And I create a new binding where I say, okay, this is warp, : fs, : directory, serve everything from this folder. If it's an HTML, serve an HTML. If it's a CSS file, serve a CSS file. And that's about it. So that's the easiest that you can do. Here I have a route that does some more interesting stuff. So I create a path that's called hello, which means I can do /get/hello. So this is a route that I'm creating for that. And let's say, okay, you have an optional argument, an optional parameter, and I create this parameter up there. I say, okay, hey, I want to have a string parameter, and if it is some, return it. If it isn't some, return at least none. So I get an option back. An option which either have a value or I have no value. And this is an optional parameter, how I declare it in Warp. And so I can say, okay, for this hello path, have this optional argument, have an optional parameter there where you can send, something like that, or Stefan or whatnot. I also say, okay, after this, let the path end. So it's not possible to write /hello /warp /something. This is not a valid route. I let the path end after an optional argument. And this is one filter that I create for this route. And then I say, okay, everything that comes into that filter, let's map it to something that I want to execute. And what do I get? I write a closure here. We heard a lot about closures today, I guess. So you know what this does. I get an optional string in there, and I say, okay, say hello to the name unwrap, or else say world to string. I guess I could just write unwrap or world. That should work too. I don't know why I did it that way. But this is how I create a hello route with an optional argument where it says either hello world or hello name, depending on what you do. And this is how you plug everything together. Here, that's also interesting. I have a 404 route, which means that for any else, so this is every other request that bubbles through, this is a filter that accepts it, create a new response, where I say, okay, my status code is not found, 404, and the body is just this 404 HTML file. And this is also a string that, a function fs read to string, which is also something that could error, so I expect it to work. And if this file isn't here, I get a 4 for my 404, and this is a very, very, very bad error message, but I was lazy, I guess. So, result of 404, I have some files, I have the hello route, and now I combine them. So I say, okay, wait for the chat. I'm going to talk to that in a little bit. So I say hello, or files, order 404. So this is the order that of priority. So I say, okay, hey, the hello route goes first. If I have anything there, that's my dynamic API, execute this. If this gets filtered out, so it's not part of this, select the file. If this file isn't available, go to the 404. And that's how I concatenate all those filters to each other. But I also have this chat here, and this chat is funny. This is the chat route. So I say, for the WebSocket, route, for the path get WS, try to create the WebSocket out of it. Try to do a WebSocket upgrade. I don't know if you know how WebSockets work, but WebSockets is basically talking over HTTP if they speak HTTP, and then sending this upgrade header. I say, hey, do you speak WebSocket? And then you get either OK back or a not OK back. I say, yeah, I speak WebSocket. Then they say, okay, let's upgrade our existing HTTP connection to a WebSocket connection. And now we can send back and forth packages. That's what it is. Basically, it is a little protocol on top of TCP then. The TCP connection stands open, and you can send packages back and forth, and the browser knows how to interpret them. The server knows how to interpret them. That's what it does. What I also do, and that's also funny, I add some users there. And users is this little data structure that I have here. Users default, that's a very simple data structure. It's basically an atomic reference count on a read W log on a hash map where I store multi-producer, single consumer senders. That's a huge type. Basically, it's a hash map of channel senders that I store with a user ID. And I just created a little type so it's easier to manage for me. And what I also do through some shading, I say, okay, if users, I want to create a filter out of it, a filter that I can use with warp, which means I say, hey, for anything that bubbles through here, map it to users.clone. Since it's an atomic reference counter, I get another atomic reference that I can work with. And suddenly I have here in my chat users available as an object. So I can, this is how I map data structures into this filter chain of warp where it just bubbles through. And then I can use the data in there. And this is what I do. So what I get is I get a WebSocket plugin from warp. I get the users to say, if this WebSocket upgrade is successful, so on upgrade, I have an actual WebSocket, and then I want to call this connect function with the socket and with my users. So this is what's going to happen here. That's a mouthful. That's a lot. And this connect function, this is what I'm going to implement with you right now. So here again, combining everything. Then I'm serving the routes, I bind it on a socket address, and I wait for that. And here, oh, there's a to-do function. So this is now something that I have to do with you. Alrighty, so let's toggle the inlay hints again because I need them when developing. The first thing that I do, I create a new user ID. Let my ID, I have one thing up there. That's the next user ID, which is an atomic usize, which means it's a thread-safe usize that starts at 1, and I can increment it across threads and across Tokyo tasks, of course. So I say, my ID is next user ID, and then I have something like fetch, add. I say, okay, basically take this one and add one to it. And how do you add one to it? I don't care about race conditions or whatnot. I say, hey, do it in a relaxed way, so increment whenever you can. Because, hey, everything that I want to get out is the next user ID. I don't care if somebody is there in front of me. Absolutely not something that I need to do. So let's print out that I have welcome user, that I have a new user. Alrighty, what I do then? So I have a WebSocket connection established. That's great. Sorry, it's my ID, and here I say it's ordering. Sorry. Better. Okay. So I have a WebSocket established. Now I want to get the transmitter and the receiver. So I want to get something where I can read from. Want to something where I can write to. And I call that, like in my architecture diagram, user TX, and I need a mutable user RX, which I do from WebSocket.split. And this is splitting is always pretty funny because if I go to the definition down there, it's split. And then I have here split. Split again, split. and again, a split. So basically, long story short, it's still one connection, but I get a reading reference and a writing reference to the same socket that I can use differently, and I need to use them differently so I can move those parts safely across threads, across tasks, etc. So this is the idea why I want to call split there, but I don't want to use the same socket for reading and writing because I want to do different tasks with. So that's the connection, something to read from, something to write from between browser and server. So, and what I want to store is I want to then use channels so I can communicate between all the existing users that are there. So I create something for the users to communicate. So that's TX and RX, and here I create a multi-producer, single consumer. Let's create an unbounded channel. I don't care about bounds in that case. So if you get too many requests, it errors. That's bad. But usually for that, what I'm doing here, that's okay. What you also see here, the types are unknown. TypeScript, Rust. That's a fraud. Rust can't infer the type yet, but it will when we move forward. So bear with me. And what I also create, so this is a sender and a receiver for the channel, so I can send stuff out. It gets received to the other side, and this is the way how I want to communicate between channels. What I do with RX, because I get a couple of convenience functions with it, I say let's create an unbounded receiver stream out of that receiver stream. And now I have an unbounded receiver stream where I can simply use it to forward everything that comes in to something else. And this is what I'm doing right now. So I create a new task. I spawn a new task. So this is the one thing that needs to be asynchronous. This is every time something happens, I want to forward everything that comes in from X. So these are the messages that come from others, and I want to send it out to the WebSocket to the browser. So this is what I'm doing here. So I say forward everything to user TX. So every message that comes in from my internal users, send it out to the WebSocket to the browser. This is what I'm doing here. And suddenly I also get type annotations, right? So now it's now a message, etc. So this is what we get here. One thing that I need to do as well, I want to add the new user. So I had created a new user, and this is why I want to store them. And what I'm storing here is, say, users.write. I get write access. Wait. It's an asynchronous operation because I'm using. Why is it an asynchronous operation? Because I'm using the Tokyo Sync RW log and not the one from the standard library. This is because those RW log write guards are not thread safe. They can be thread safe if you know how Tokyo shuffles or async shuffles those tasks in between across the wait blocks, but that's a lot of stuff for you to do on your own. That's why Tokyo provides you with an abstraction layer on top of it, so you can use it easily within your Tokyo applications. And you can have everything like mutex as well, or TCP listeners or file listeners. There's always a variant of that works really well with the runtime. Also with the same API, which is nice. The only thing that you need to do is wait for it. And once you get it, let's insert based on the idea that you have this one sender. So what I'm doing here, I store all the senders, all the transmitters for all my users in this bookkeeping data structure. That's what I do here. I'm not using a mutex because mutex means it's locked for reading and writing, and RW log means once I lock it, others can still read, which is interesting for broadcasting later on. So it's a little bit faster in certain scenarios. Okay, let's do that. Now I have this here as well. Okay, dokie. So now I created the connection. I said, okay, everything that if I have a message internally to broadcast, send it out to the WebSocket, store the sender, and now I need to use the sender. Now I need to broadcast stuff. This is done by listening to messages from the WebSocket incoming. Let's say I have some result, which is user rx dot next. So it's a stream. It's an asynchronous stream. I get little messages in. I wait for them, and once I do that, let's broadcast this message. So I create a little function. Broadcast, it's an async function, broadcast message. The message is of type message. That's what comes in from a WebSocket. So you see warp filters, WS for WebSocket. That's a WebSocket message. That's great. And I want to have a reference on my users. And then I say, okay, for if let okay string message or str message. I don't need that, I guess. Do I need that? I don't know why I need that. I guess this is an operation that could fail, but I want to have it because I want to send strings. I want to check if this is a string message. I guess this is what I want to do. It's been a while. So if this is a string message, let's get all my users from the user data structure. And it's an async stream, so I have some sort of iterator. No, that's an actual iterator because I'm now accessing the hash map. So I'm reading the RW log, I'm accessing the hash map. Now I have an actual iterator, and I say, okay, for every sender that I have here, send a clone of the message, and failed to send message. So this should be it. That's the broadcast message stuff. That's great. And here I say, okay, broadcast message, and the message is the result. And unwrap it, so I expect failed to fetch message. That's also a result type. Alrighty, okay, that looks good. I'm already broadcasting. Oh, I have some troubles here. I guess I need to have a semicolon in there. Now we are good. This one, oh, okay, that's an asynchronous function. So I definitely need to wait that. Thanks to Rust Analyzer for letting me know. Okay, now for the last part, this is something that I don't need. I want to also write the disconnect message. So if something, if one of the users is gone away, I want to disconnect them. Let's hit disconnect the user ID from users. Yes, okay. First of all, print line goodbye user ID. There we go, and say from users. Users of blank, so you can have it centered in the screen. For users, write or wait, remove my ID, because it's a hash map I can just call remove there. Oh, that has been something. Where do I put the disconnect now? So how do I say that I disconnect the user? And this is great. This is great because we have here an asynchronous stream, and this one returns either a result or it returns none. And when does it return none? It returns none the moment the connection drops. The moment the connection drops, this next returns a none, which means this whole while block ends. I don't get any messages anymore. I can safely disconnect. Yeah, that's it. I can safely disconnect my ID from the users. And I, of course, need to await that too, because it is an asynchronous function. And what I like especially about this is that first, bookkeeping, that's establishing a connection, reading and broadcasting messages, disconnect. That's sequential. That's a 4-step solution to having a WebSocket application. And the only thing that I need to do as synchronous is this particular line. I say, okay, everything that comes in from X, forward it to user X. I don't want to have that in my synchronous code, right? What synchronous? In my sequential code. I want to have that somewhere else. This is a standard task. Work on that. Just forward that. I don't care. The rest is bookkeeping, establishing a connection, reading and broadcasting messages, and disconnect in the end. And this is the only thing that I need to put aside, this only little Tokyo spawn. Of course, I have lots of awaits in there, which means there's lots of little tasks, because basically every await is some sort of checkpoint for Rust to say, okay, this is one package, one part in this future state machine that I can execute independently. This is with every await block that there is. But everything that I need to shove aside, which I need to not have in my sequential flow of code, is this line. That's everything there is. Couple of live coding. Let's see if it works. I don't know. The old one worked. Look at that. There you go. Let's see. Cargo run -- release. Okay. I have a server down here. Building. In the meantime, I'm opening up another connection. And what I'm also opening up is for you to look at. That's an index.html file. It does nothing but loading a main.js file. The main.js file is very, very simple. It creates a new WebSocket connection. That's that. It opens it. That's great. It's connected. On message, it says, okay, receive the data and put it in some text content. And on send, it sends some data. That's all there is. It's nothing fancy at all. Just getting messages, sending messages. Not even jQuery in there, because I clopped it together really, really quick. Okay, back to the terminal. Okay, I have a running server at this URL. So if I say curl localhost 8080 hello, then I get hello world. If I do it with hello Rust Linz, I get hello Rust Linz. Oh, that's great. That already works. Now let's see what happens if I want to curl localhost. Static file, that's great. You can see that I tried it with Actix first. Now I switched to Warp. That worked a little better. So let's do even more stuff. Let's open up a browser. Let's go to localhost 8080. And say hello. Oh, I didn't implement return. Hit send. Hello. Cool. Oh, that's great. I just got everything that came up from here down there. That's super great. Via a server round trip. That's easier, but it's even better if I create another browser window down there and say, how are you? If I click send here, let's see. Ta-da! It's here as well. I'm great. I just coded a web server, a web socket server, live on stage at Rust Linz. Alrighty, and that's about it. That's the demo. So in the end, one advice that I can give you if you want to develop a WebSocket server on your own, that's a very basic demo of establishing that. Tokyo gives you a lot of stuff to wire everything together, to plug something in and send messages via channels and opening connections. So this is all part of Tokyo. Everything that happened after WS, after I had this WebSocket connection established, is pure Tokyo. It's not part of the framework. And this is also the reason why I was able to do that. Because those frameworks like Warp and Axum, they build on top of those Tokyo primitives, which means everything that they can't provide on their own, you can do yourself with those Tokyo libraries. If you have a web server like Actix, or if you have a web server like Rocket, a framework like that, stuff like that becomes, in my experience, increasingly harder because they are opinionated. They are opinionated, which also means that WebSockets need to work according to their opinion, which is great. You know, you want to have an opinionated server because it moves you fast. It brings you up to speed, but also you need to wait until they decided on their opinion on those topics. I guess WebSockets is on the roadmap for Rocket, which is great. I'm looking forward to that. I'm really looking forward to that, how they solve it, because it's. I think this is a challenge. I tried to implement it with Actix and needed to work with the actor model, which was way too tough for me to understand. But I think it's doable there as well. There are some tutorials out there. I found this to be the easiest version. And I think if you use Axum, which is a declarative web framework from the Tokyo folks, you end up at the same point where you suddenly get all those primitives in your hand, where you can create channels, where you can create sockets, and you can split them, and you can write them, and you can read them, and then you can do all the message passing around it. So that was my talk. I just go back to, I don't know, about 160 slides there and say, thank you very much. That's about it.
Stefan, that was a really, really great talk. I really enjoyed it. I learned a lot. Thank you very much.
Thank you.
And I think people also liked it. Did you check the messages? You see, nice. You make it look so easy, and a lot of, or here is super cool. Here is in fact a question from Carlos. Up to how many WebSocket connections would this broadcaster scale? What do you think?
That totally. So the perfect answer for anything computer related totally depends. It depends how many sockets that you have available on your machine. This is ending at some point. So you just have so many sockets, and I don't remember what the technical maximum is for that, but I guess a couple of thousand. But that's actually something where I can't give an exact number with that. The thing is, so a WebSocket is just, quote unquote, just a TCP socket. Which is important because usually servers and operating systems and browsers can handle a lot of them. And they are very, very lazy, they are very lightweight, they are very operating system related. WebSocket is just a protocol on top of that, which means you just send it in a special format so your server and your client can understand what you're talking about. But underneath, the same rules are for TCP sockets as well. So that's the number. You have as many WebSockets as many as you have TCP sockets. Exactly how much memory is it using now? I have no fucking clue. Sorry. Little bit.
One comment on that. That might be also an interesting talk. We are using WebSockets pretty heavily whenever we want to have a back channel from the server to many clients, even in business applications where we do async processing of transactions, for instance, using some message broker like Kafka or Azure Service Bus or something like this. And what we essentially do to get around this problem of scaling is to use a platform as a service or serverless offering in clouds where they offer you a scalable WebSocket termination. So essentially, the clients do not connect to your implementation of WebSocket, but they connect to an implementation provided by Microsoft, whatever. I know the Microsoft Signal R implementation in this case. And in the backend, you essentially communicate using a REST API. So they translate incoming WebSocket messages into a REST API call, and you can send messages out to users and groups using a REST API. That has nothing to do with Rust, but in the topic of scaling WebSockets, I found this approach pretty good, because then I don't have to think about scaling at all, because these serverless services, they scale like hell. They easily support hundreds and thousands of connections, and you don't have to worry about at all. I really like that.
Absolutely, that's the big benefit of having infrastructure as a service, that those infrastructure needs are not your concerns anymore. And I think for a lot of use cases that works. One thing where I developed WebSockets in the past was for online betting solutions. Getting it's Quoten in German. It's not quota in English. No. It's not that. Let me Google that, because I always mix it up.
I will do that for you.
Give me a second. I have to look it up.
Betting odds.
Yeah, the odds. Where you get the odds. Thank you. Where you get the odds as fast as possible to your web client, because when you hit the buy button or the bet button, milliseconds are important for some people. And this is where we use WebSockets, and this is where the moment you reach the connection from one of those infrastructure layers where you are where they are managing WebSockets for you, to something that is serverless, which has its very own infrastructure concerns, as opposed to your layer.
Absolutely.
You want to have that a little bit closer to each other, and you want to have this WebSocket available immediately. And this is where I would say, okay, this is a situation where it might not be the right tool, but for everything else, absolutely. If you can if you can afford it, if the push to a client is more important than the real time, and real time is always in the eye of the beholder. But if the push is important to you, use one of those services, definitely.
Mm-hmm. Awesome, very good. Okay. I think we are at the end of today's Rust Linz meetup. Yes. So, people, thank you for joining us. Thank you for participating. And thank you for all the great questions. Don't forget to check our website and to register on our meetup. Stefan and I will maybe hang around a little bit on the Discord server. So if you have questions, maybe we will not answer them immediately because it has been a long day for both of us, but we will definitely come back to you. And again, if somebody in the audience has an interesting project or an interesting learn or an interesting crate that you came across, or you're writing a book and you would like to tell us about, contact us. We are still looking for guest speakers, especially for next month. One is already fixed, and the other slot is still open. We would love to have you at one of our upcoming meetups, don't we, Stefan?
Absolutely. And if possible, I just saw one more message from Hussein. Hi. It's great. It's great that Hussein is asking a question, and I want to answer that because Hussein was in my Tokyo workshop today.
Nice.
So great for doing the extra round. That's wonderful. And Hussein asks, if the client closes then the chat window without explicitly sending a close message, how does the server recognize this aspect? And this is one of the niceties when working with Rust, because what happens, you have a TCP connection, and TCP connection is terminated. So the moment you close it, the browser sends a terminate signal over TCP to your server. And for the abstraction layer on top of Tokyo, for this asynchronous stream, for this iterator, it means that, let me quickly put my screen up there. Sorry, wrong version, this one. It means that this thing here returns a null value. I don't get any values anymore. This stream says the connection has been terminated. You're not getting any values anymore. And with that, you can disconnect your user. You remove the user and the channel out of that. This is where the disconnect was done. And at the end of this block, now I've reached this block, Rust takes care of freeing all the memory for me. That's the nice thing about it. So yeah, thank you for this last question. And other than that, I agree with everything just Rainer said. If you want to, maybe just show what you've been working on. So this talk from me just was, hey, I solved the problem. I want to share it with you. If you have stuff like that, reach out to us, either on Discord or send us a Twitter message or whatnot. This is your chance to share it with the world and to get people talking about it and to get feedback. So this is also why Rainer and I created the Rust Meetup. We wanted to have feedback on our Rust projects and our Rust code, and this is also a forum for you. So if you want to share your thoughts, share your ideas, our doors are open. Beginners are welcome. If you're a first-time speaker, if you're a Rust newbie, don't worry. This is your stage. Alrighty.
Absolutely. Enjoy the rest of the evening, Stefan. I wish you a very nice evening after a long
Thank
day.
You very much.
So enjoy your evening beer, play with your children, or whatever you want to do. I'm looking forward also to a very nice evening.
Absolutely. Thank you very much. Alrighty.
Goodbye.
See you.
Bye.
Bye-bye.